remember we started talking about the relation between classes, and we have seen the has, which is the composition. And after that, we talked about inheritance, which is the is relation. Okay, so this is the is or inheritance. And we know from the previous course that inheritance will help us, and this is why they included in the object-oriented paradigm. It will help us create new classes based on existing ones because we inherit everything from those classes. Okay, so we have seen how that will happen, and we have seen the relation between constructors and how they help us get the objects from the subclasses. Now, inheritance will create some issues, but it will also offer us some solutions. So one important thing related with inheritance is called overriding. Now, we have talked about several weeks ago about another concept which starts with over, and it was called overloading. Okay, and by overloading, we know that we can create multiple functions with the same name, but with different input arguments list. Overriding is similar to that, but is related directly with inheritance. So overriding is going hand in hand with inheritance. And these two concepts together, they will define the polymorphism concept in object-oriented. So overloading plus overriding, okay, equals like that stuff which is written on trees, equals love, but in our case is not love, is polymorphism. So remember that the concept of polymorphism is based on overloading and overriding. Now, if you check the history of this word, you will see that this means to have things or entities that look the same. Remember, they have the same name, the functions, but they behave differently. So that's why you have polymorphic. Virus is polymorphic software, which means they change, they look the same, they keep the appearance, but they change their behavior. So this is the case with functions. And overriding and overloading, this applies to functions. Okay, so their main subject are functions. So we will talk about overriding. And another important concept which is related with overriding is called virtual methods. And here we will have a derivative of virtual methods, which are called virtual pure methods. And this name is specific to C++ because in all the other object-oriented languages like C# and Java, they are called abstract methods. Okay, from this one, we will talk about abstract classes. Okay, so these are the concepts that we will cover today. So I will keep the classes simple because I just want to help you see what's the scope of this concept and how they actually helping us. So for example, we have this software which is handling persons. Okay, so we start with the generic software for managing human resources. So here I will have string name and maybe age. And let's say we have, yeah, I need to include, to use the standard namespace. Okay, so right now I have this class person. I don't need copy constructor, destructor, and other stuff because I don't have any dynamic fields. Okay, so I will just define, let's say, a constructor here, the default one. Okay, don't forget to initialize this data here, just to be sure you get the same values. Now, maybe here you want to change that. It's your option. Let's say John Doe. Okay. And I don't know, age, we keep that age, let's say 18. Okay. And here I will define also the constructor with arguments. String name, int age. Let's name this with caps, just to make the difference. And here I will use the constructor initialization list. So this will be name, and age. Okay, and that's it, because the constructor is not doing anything else. So we build this software, and let's say here we have this a method print info, where I will just print the name of the person. So this name, something like this, and here I say this age, years old. Okay, so I have this print info. Now, let's imagine we have a software solution which manages this kind of persons. So let's test one. Person John. Okay, with the name John and age 21. And now let's print John data. Print info. Okay, so if I build this and run it, we should see this message on the screen, which confirms us that everything is okay. John, 21 years old. Okay. Now, we have this app, and later we decided to use it to manage students. So this app is already managing all the personal data of persons. So let's imagine we have here all the attributes that a person can have: birth date, location, address, whatever you think, email, and so on. So right now we want to use this software as a base to develop another solution which will be used by the faculty to manage students. So here we know that instead of copying this class person and rename it into student, we can do this. So this is inheritance. We can say we create a new class based on the existing one, okay? And this is the inheritance. And here I will say, hey, a student will have what? A faculty and maybe some grades. But let's say here I have only the faculty, just to keep this stuff simple. Okay. Now, we know from last course that here, if I want to create a constructor or to manage the constructor from the student, because if I write a constructor like this one, I know I inherit everything from person. So I have a name, I have an age, and now I have also a faculty. Okay, this stuff is inherited, and I can actually use it here inside my class. And we know from last week that in order to make these private encapsulated attributes available to the student, so now I can write this name equals name, because now I will get the is inaccessible. We know that here we should define these values like protected, okay? Because in this way we have access here in the child subclasses of person. So protected is very useful in this case when we do inheritance, because you see right now I can write this name, okay? This age equals age, and this faculty equals faculty. Now, we know from last week that actually when a student object is built, this constructor is helped by the parent class constructor. So right now, by default, the compiler, it's calling the default constructor from person. And even if you don't write this, the compiler will always add this. And we have seen last week that if we don't have the default constructor, then here we will have compiler errors. Here it will say, you see, there is no default constructor. Why? Because this constructor automatically will call the parent class constructor. And remember, the order is parent, and after that student. And also we have seen that for destructors, the order is in reverse. The first part is the student part, which is destroyed, and after that, the inherited part. Okay, so we have seen this in detail before the holiday. So remembering this sometimes is much more useful, even if you have the default constructor here, is much more useful here to actually take control and to say, hey, I don't want to rewrite this stuff. I want to use the constructor with arguments from person. So you have this power. Now, sometimes it's necessary to do this when you don't have the default constructor, but sometimes you have the liberty to do this. So in this case, this doesn't make any sense, because now I'm explicitly calling this constructor, which is setting up the name and age that is receiving. So I don't need to initialize those values. Okay. So this was the story. This is like a fast recap. And right now, if I create a student Alice, okay, so this is Alice, age, let's say 20, and faculty CA. If I call alice.printinfo, then, and run this, debug start without debugging, let me show you, we see the printinfo method, which says Alice has 20 years old, but where is the faculty? So this is the first issue of inheritance. Okay, we inherit a lot of methods. We like them, but you see the methods are limited to the context from which they come, to the context where they were defined. Obviously, printinfo here doesn't have any clue about a faculty. You can't write here faculty because there is no faculty in the person. But the faculty is an attribute which we add in student. So how can we print Alice data like name and age plus the faculty? So the first idea will be this, to create another method, print student info. Maybe here we can say, you can copy paste this, okay? And after that, we can add the faculty. So cout end line. And here I will say enrolled at this faculty. Okay, and now you see, I have a function which I inherit from person, but now I have also a function which is specific to students. So now I have two functions, and this is like, you need to know that printinfo is printing only the person part from the from a student, and print student info is the one which prints everything. So if I will run this, okay, obviously I will see Alice, 20 years old, enrolled at CA. Okay, now what's the issue with that? Let's suppose we have work with person a lot. So every time you will be tempted to use printinfo because this is the function that we were using. This is the function we were used to have in our programs. And right now, you see the complexity of this solution is starting to increase, because if you have here multiple functions which do stuff for a person, and you want to make them to print additional data in students, so you like the behavior, but you don't like that is incomplete because it's not covering new attributes, then here you need to, is like rewriting all those functions from here in the new context with a different name. So now the number of functions that you need to manage for a student will be bigger. And every time you need to remember which one is which, okay? What's the difference between printinfo and print student info? So which will be the easiest way? If we have the power to choose the way this language has been designed, what would you prefer? So here, if you ask me, I will say, hey, can we have only one function? So can we have only one function, print info, and that for a person will work like here, and for a student will work like here? And the answer is yes, because you see, in terms of productivity, managing only one function instead of deciding to choose from different functions with which they do similar stuff is much more easier to manage only one function. In that case, this is possible, and it's possible because we can override functions that we inherit. So overriding means re-implement or rewrite methods inherited. You see, that's why I said earlier that this works only in the inheritance, only when you have inheritance. Because if this class is not inheriting any other class, you can't do overriding, okay? So overriding means rewrite methods inherited. Now, what means overriding? Means take the function signature from your parent class. So you need to take it. You are not allowed to change anything. This is not overloading. If you by mistake right here, something like this is not overriding, this is overloading. Why is overloading? Because you see, you inherit this version without arguments, and now you define another one with an integer. Yeah, but this is overloading. So when you override, you need to keep the signature. You are not allowed to change anything, okay? So what do we do here? We do this. And right now, I don't need the print student info because I have in the student class, I have a method print info, which has the same name as the one from person. So now I have only one method, but this print info now it's, you see, it's doing more because in the student, we have also faculty. So if I will compile this, the compiler, it's okay with this. And if I run this, start without debugging, and show you the output, you will see this. Okay, Alice, 20 years old, enrolled at CA. Okay, so right now, by overriding methods from my parent class, now I can change their behavior. And this is overriding. Yeah.
So basically, the program simply recognizes that we also have another field, and that means we go to the second class with the inheritance, and therefore we get all of the
now, if you are the compiler, let's play this game. Let's imagine we are the compiler. What information do you use here and here in order to determine which version of print info you use? What's the information that will give you the answer?
The parameters.
Yeah, but which parameters? There is no explicit one here, but remember, all the functions which are defined in the class, in order to call them, you need an object, right? And that object is this in the function. So this print info and this print info requires an object in order to be executed, right? To be called. So what's the type of John? Person. What's the type of Alice? Student. So what's the information that the compiler is using in order to determine which print info to call here and here? The type of the object which is calling the method, right? Because if Alice is a student, when you say Alice don't print info, you will execute the method from which class if Alice is a student? From student, which means you will call this. If John is a person object and you say John print info, you will execute which method? Print info from student, from person, sorry. Okay, so in this way, the compiler determines which version of the overridden function to execute. It will always check. It's like asking this object, hey, what are you? And John is saying, I'm a person. Okay, so you have print info from person. It will ask Alice, what are you? I'm a student. So it will call print info from student. Okay, so this is the information. Because remember, when you override, you are not allowed to change the signature. So if you have here another method like do something, I don't know, pay tax, okay, float tax value, whatever. If you want to override this one, you need to take the signature, because if you change anything here, if you change the name, it's obvious, you define another function, which is not the inherited one. If you change the arguments list, this is overloading. Overloading means multiple functions with the same name, but with different arguments list. So don't change anything. So right now, this is the overridden version of this one. Okay, so this is the rule of overriding. And these are the benefits. We don't need to make new functions in the inherited classes. We can keep the same functions, and now the code is much more cleaner. You don't need to remember a lot of functions. We can reuse the inherited ones, but we can make them smarter. We can make them do more. Now, if at some point you need the version from your parent, so let's suppose you don't want to rewrite this stuff. and you want to call the person version. Okay, so let's say calling the person version of print info. If you want to do this, you still can, but watch out. Don't write this. If you write this print info, this is calling this method. And if you do this here, this is the infinite recursion, okay? Because this function will call itself forever. So if you want to call the person version here, you need to say person print info. Okay, so when you override methods, but you still want to call the version from your parent because you don't want to rewrite or redo that stuff, this is the way you do it. Okay, always you need to put the name of your parent class here. Okay, because now the compiler is saying, aha, you don't want this one, you want the one from person. Okay, so you need to use the class name specifier here. So build, rebuild, and debug start without debugging. Let's try again. And we have the same output. Okay, Alice, 20 years old. This is from the version of from person, and this is what we add here because we execute also this line. Okay, so this is the overridden concept.
I have a question,
yeah, please.
but it might be silly. If we have a class that has inherited 2 or 3 or more classes, can we do this for the first one, like the
okay, that's a very good question. It's not a silly one. It's a good question because I forgot here. Well, I wanted to talk with you about multiple inheritance. So thank you for the question because it's actually help me remember this. So your colleague is saying this: what will happen if we inherit from multiple classes, which is possible in C++, but I will give you one reason. There are millions of reasons not to do this. And that's why in Java and C# you can't do it because it's dangerous. So you see here, I have a student which is inheriting a person. Let's suppose here I define another class, which is called software engineer or programmer. Okay. So, and here maybe you have a string company. Okay, now, if I want to do an intern, okay, so if I want to create an intern class, students which are going to companies to do their internship, then I can do this intern, which publicly extends student, right? And publicly extends software engineer. Maybe you do an internship as a programmer, okay, in a software company. So when you do this, maybe here I have, I don't know, mean hours, the minimum number of hours that you need to do in order to finish your internship. So if you do this in C++, you see it's possible. Now I will inherit everything from person. So I will inherit, student. So I will inherit faculty, but in the same time, I will inherit from person because students is inheriting person. I will inherit a name and age. I will inherit all these methods, and print info is already overridden in student. So I will inherit the last version of it, which is print info. And in the same time, I will inherit software engineer. So right now an intern has name, age, faculty, and company, right? And your colleague is saying, what will happen? Just correct me if I understood wrongly. What will happen if I inherit the same method from these classes? Maybe student has a print info and software engineer has a print info. How can I do this to override the first one? Okay, to override the version which is from, let's say, company, from the first class, like student, this company, right? This was the question. How can I override here in intern the print info from software engineer, from
no,
student?
I actually asked if we can inherit the one from the person, if it's not a problem to do so.
So right now you inherit student. So in terms of overriding, you will always inherit the last version. So right now we inherit print info from student, which has been overridden here.
Yes.
So if you create a software engineer, an intern, and you call print info, we will see this version from here, from a student. Okay, so this is what's happening right now. Your question is, can we inherit not the one from student, but the one from person? That was the
Yes.
question.
Yes.
No, you can't. But if you want to change again print info here in intern to make it call the one from person, again, you can do this. This person print info. Okay. And now you
It's
see
a hierarchical relationship between them.
Sorry?
It's a hierarchical relationship between the classes.
Yeah. And now the compiler is saying, okay, I will provide you here the print info from person. Or if you want to use the one from software engineer, you can do this. Software engineer print info. So you see in a hierarchy, now you have the power to choose which version. Let's make this public here. You have the power to choose which version by using the parent specifier. Okay, so this one will call the version from person because explicitly I require that. This one will actually call the print info from software engineer. But if you write here, because I will generate infinite recursion. But if you write here this print info, this is the problem with multiple inheritance. The compiler is now saying, sorry, print info is ambiguous because you have a print info from student, which is this one, but in the same time, you have a print info from software engineer. So at this point, every time you want to use print info, you need to say from which class. You want the student version, you write like this. You want the person version, you write like this. You want the software engineer, you write like this. Okay. And this is one reason, one issue with the multiple inheritance. Another issue with the multiple inheritance is what will happen if here you have age. You see, now how many attributes age an intern has? It has one which is inherited from this line, person, student, and one which is inherited from software engineer. So when I write, let's say, do something, just to give you a glimpse of the issues with multiple inheritance, do something. And here you want to write this age equals 23. The question is which age? You see, is ambiguous. So right now you need to decide, because you have two age attributes. Which one do you want to use? So you want to use the age which you inherit from the student, or you want to use the age which you inherit from software engineer. And now it's forcing you to write the code like this, protected. Okay, which you see, it's making this quite complex. Okay, so you need to know the entire hierarchy. And actually here age is not directly from student. The student is getting age from person. So these are the many issues with multiple inheritance. And in C++, this is possible. So we can do this, but it will actually increase the complexity of the code. And generally it's agreed, if you don't handle this with care, it will generate more issues than it will solve. And that's why when they design C# and Java, you don't have multiple inheritance in those languages. Okay, you are allowed to extend only one class, and that's it. Because this creates issues even for experienced programmers, especially if you don't know the entire history of all this inheritance. So you know that intern is inheriting student, but do you know what student is inheriting? And so on and so on. So you can have multiple issues. Just to give you another issue, what will happen if you extend this also from person? And this is called the diamond of death. why it's called the diamond of death, because you inherit person 2 times. Okay, so if I will draw this, it will look like this. So you have the person here. One sec. So you have this person here, and after that you inherit person here in student, and after that you did the same here in software engineer. Okay, and after that you inherit from both student and software engineer an intern. So how many names you have? You have 2 names, one which is inherited from this path and one which is inherited from this path, and this is called the diamond of death, because it will just eat you a lot of time just to figure it out which attributes you want to change. Because when you create an intern, remember, the person constructor is called, the student constructor is called, the software constructor is called, and then the intern constructor is called, and they all might change attributes here. Okay, so that's why this is called the diamond of death for multiple inheritance. So that's why I will not ask you to do multiple inheritance at the exam, or I never had this requirement if you check the project specifications, because it's very, very tricky, and you can easily do mistakes and lose yourself here in all this stuff. But thank you for the question, because this was another topic to clarify to you why we are not insisting on multiple inheritance. And that's why in the languages which you will use next semester, they don't have multiple inheritance. Okay, they don't have multiple parents, because many things that will happen here, they purely depends here in the order of this enumeration. For example, if you extend from software engineer and after that from student, different stuff will happen here differently, because now you change the order of the constructors, for example, and so on and so on. So this order has a tremendous impact on how stuff will happen here in this class. So again, very time consuming. It's increasing the complexity of the solution, and generally it's creating a lot of issues rather than solving. So please don't do it if you are in C++. In other languages like C# and Java, you can't, which means you are safe. So this is the overriding concept. Okay, so we can actually make functions behave differently. We can keep print info in all these classes. Okay, so this is overriding. Now, what's the idea with virtual methods? So you see right now, yeah, let's make this software engineer. Also, it's extending person here. So let's call here also this person print info, because I will also print the name and the age of the software engineer, but I will delete this age here. Okay, so I don't want to confuse you to have multiple age attributes. Okay, so I have only one, which is inherited from person. So right now we have this framework of classes, and when you hear framework of classes, means classes which are related to each other by inheritance. So you see, I have a software engineer which is extending a person, and I have sorry, not an intern, we will not deal with that, and I have a student which is extending a person. So right now, if let's say this is a software application which is managing students, software engineers, and persons, then right now we need to deal with 3 types, right? Because in our software right now, we have a software engineer, okay. Let's say this is Bob, engineer Bob, okay. And yeah, the default constructor doesn't require brackets. We have John, which is a person, we have Alice, which is a student, and we have engineer Bob, which also has print info. Okay, so right now in this software, even if there is a relation between these classes, so student is a person, software engineer is a person, I need to have, you see, different variables. I need to handle them differently. So I have a person object, I have a student object, and a software engineer object. Now, if things will become complex, at some point I need to manage multiple persons or multiple students or multiple software engineers. So when we do that, obviously we need to create arrays, right? So here I will have an array of persons. Okay, let's say 5 persons. Here I will have an array of students. Okay, 5. And here I will have an array of software engineers. Okay, again, 5 engineers. And you see, each time we need to, yeah, here he's saying we don't have a default constructor for students. So let's add one, because otherwise I can't create that array. But I will show you another way when you don't need this default constructor. But what I want for you to see is that right now, you see, we need to handle them differently. So we need to have an array for each type. This will be the conclusion, right? We have an array for persons, we have an array for students, and we have an array for software engineers. So they are kind of related, right? So they are all persons. So the question is, can we manage them like persons? So this will be, can we manage them like a person? Because if I succeed in doing that, it means I don't need 3 arrays, right? I will need only 1 array, which will be called everyone. So I can put into that array software engineers, students, and persons. That will be great, only 1 array. So let's try to do this. Let's see if I create a person, P, can I copy John or John, I surely copy. Can I copy Alice into this generic person? Let's see, person equals Alice. And I see the compiler, it says nothing, because it's kind of the compiler is realizing that a student, which is Alice, is extending a person. So for example, if you have here another class, vehicle, let's say I have a vehicle class, which has no relation with person. Let's see if I create a vehicle here, the vehicle, can I copy it into a person? And in this way, I prove to you that this works only for classes which have this inheritance relation. So can I copy the vehicle? And if I do this, you see, I can't. It's saying, hey, I can't copy the vehicle into a person. But it didn't say anything about a student being copied into a person. So what's the conclusion? If you have classes which they have this inheritance relation, you can by default, so you don't need to do anything extra. By default, you can actually copy the child type, the child class, which is in this case student, into a parent object. And this is called, remember, we named this operation when we change the type of things, we call it cast, and we also overloaded the cast operator. So the action of changing the type of different stuff is called casting. So this is called upcasting. Remember, this is a very important term. It will help you speak like a pro in Java and C# and in other object-oriented environments, upcasting. Now, why is this called upcasting? Because if I will draw the relation between classes, so right now I have this simple framework, person, which is inherited by a student and is inherited by a software engineer. Okay, and I have this relation between them. This is called upcasting because you see, by default, I can cast from a bottom type towards a person. And this works at any level of this framework. For example, if you extend student into master student and PhD student, you can upcast a master student, something from this, into a person. And again, it doesn't matter how you extend this framework by just extending other classes into other classes, and you create here like something like a tree. It doesn't matter. Upcasting will always work. So remember, upcasting means I can copy a student type or a child type, a class type from this framework into its parent. It doesn't mean it's direct parent, any parent, okay? So this is called upcasting. Now, why this works? And there is a trick here. At this point, it doesn't work as we can imagine. Now, why this works? Because remember, we talked about the structure of the objects before we went into holiday. And I said to you, hey, when you have the student class, okay, a student class is like this box, okay, a green box. But because you inherit person, you have the person box inside of it. And here you have all the other attributes specific to a student. So this is the person box. Now, in memory, so this is our imagination. In memory, if I will draw this in memory, this actually looks in a linear shape like this. The box is not inside the box, is actually they are concatenated. In memory, from left to right, at the beginning of your object memory, you have the inherited part. And after that, you have the new part. So they are actually like this in memory. And this is actually, let's say this is a student. So here you have the person part. Okay. And here you have the new part, the student part with the new attributes. So they look in memory like this. And we read the memory from left to right. Now, when you copy a student, you see Alice is this image from here, a red box with a green box. And a person is just a green box, right? So the person is just a green box. Sorry, it's a red box. This is the person. Okay, so this is the person. Can we copy this red box and green box into this red box? Naturally not, because we can't, because the size of these two parts is bigger than the red box. But if we choose to be ignorant, if we choose to ignore everything which comes after the red box, we can copy it, because you copy only the red part. And that's why upcasting works. Because when you do person equals Alice, you choose to copy from Alice, which is a person plus the student part. You choose to copy only the person part. So right now, we are copying from Alice only the name and age. And the faculty is still here in the green box. Okay, so this is upcasting. It will copy only the part you inherit from that type. Okay, because in memory, they look like this, and it's quite easy. They say, hey, what's the destination type? It's a red box. What do we have here? A red box. That's great. Let's copy it. And they just ignore this. So it will not copy this part because they don't have space here. Okay, so they will copy only the first part. Okay, so this is upcasting, and this is something we can do when we have classes which share this inheritance relation. Now, the opposite cast, to convert a person into a student, for example, if I try to say Alice equals person, this doesn't work. You see, it's saying I can't copy a person into a student, and this is called upcasting. Downcasting. Okay, so downcasting and upcasting. Why downcasting? Because you see, we cast downwards. So we take a person and we want to copy it to convert it into a student. So that's why it's called downcasting, and it's not working. And if you go back to this image with the boxes, it makes sense. Why? Because when you try to copy a person into a student, you are actually trying to copy this red box into something which has a red box and a green box. And now the compiler is saying, hey, I can copy the red box here over the first box because they have the same color. They are identical. But now the question is, what do I write here? Because equals needs to fill up the destination. So the destination is a red box and a green box, and you are providing to equals only a red box. So that's why downcasting doesn't work, because the compiler has no idea what to do in order to fill also this part of the destination of Alice. But you see, when you want less, it's okay, because upcasting means I want less. So I want only the red box, which is okay because you take only the red box. So right now, using upcasting, I think we have a solution. Instead of doing 3 arrays, I can actually create only one array, person, everyone.
I have a quick question.
Please.
On line 110, for example, why couldn't we have a dynamic array?
Here, we can have a dynamic array.
Wasn't it an error?
No, I was trying to write it as in Java, like this. But actually, you want like this. Or not,
Oh.
it's C++, is not way. In Java, this will work. So a dynamic array is only like this.
Okay. So,
Yeah.
okay.
Yeah. So, but we will reach dynamic arrays. Just wait. In 10 minutes, we are there. Because we can't do this, everything with this. They are limited. So let's see if we are getting close to our objective, to have one array for everyone. So let's see. Everyone index 0 equals, we have a person, John. So let's copy John here. Everyone index 1 equals Alice, which is the student. And everyone index 2 equals engineer Bob. Everyone. So it works because we are using upcasting. So right now, instead of having 3 arrays for persons, students, and engineers, I can have an array, and this is important. This type here should be common to all of them. Okay, because I showed you with the vehicle, you can't do upcasting. So they need to have this relation. So person should be something common to all those classes, should be a parent of all those classes, like student, engineer here. So if I go through all these objects, okay, and now I do this, everyone at index I print info, I should see the information from all those objects, right? If this works. So cout end line, upcasting. Okay, so let's see. So what should we see here? We should see John, Alice, and engineer Bob. Now for engineer Bob, let's add some, where is engineer job, software engineer here. Company, let's say company by default, I don't know, Apple. Okay, so we should see Apple, and also let's set a name. Or yeah, we will see John Doe because we're no name and age 0. But we will see, we should see Apple, right? Okay, so if I will run this, build, rebuild, start without debugging, let's see. We have John, 21 years old, Alice, 20 years old, and John Doe, 18 years old. So we see the data. So this is engineer Bob because we don't have a constructor, so we don't set a name there. But I see John, I see Alice, and I see John Doe. Now, what's the issue here? So I think we are very close to the solution, but something is missing here. Remember that in student, we have overridden the print info method. So in order to see enrolled XC, and you see, we have also, I think, overridden print info in software engineer to print the company. So this is the print info for engineer Bob, and this is the print info for Alice. But when we put those student software engineers in a person array, we see here only the print info from person. We see here only John, Alice, and John Doe. We don't see the company and we don't see the faculty. So how can we solve this? Because if we solve this, we have it. We have the perfect solution. You have only one array and you put them everything there and you override methods, so you don't need to invent new methods, and the code will be quite simple and you can handle multiple things in the same time. Now, let's see. If I will draw the memory of all this stuff, let's see if static arrays can help us. Remember, we had the game static arrays versus dynamic arrays versus pointers. And I told you that I think pointers are already leading, but today we will give the final blow to static arrays. So if I will draw the memory, so this is a person, right? This is a rectangle. Now, a red rectangle and a green one, this is a student, okay? And a red rectangle and the blue one is the software engineer, okay? So this is how these three objects look like in memory. So this could be John, okay? This is Alice, and this is engineer Bob, okay? Because they have different types, but they share in common this. Now, if we draw the memory of the everyone array, how this will look like in memory? Sorry, wrong color. So this is the array everyone. You have what? A red rectangle, and a red rectangle. This is everyone. Why? Because everyone, when we have defined it, it's an array of persons, everyone. Okay, so when we copy, doing upcasting, John, you copy this here, no problem. When we copy Alice, we understand that it's copying only the first part, the red box. Okay, so here you have name and age for Alice. And when you copy engineer Bob, again, you copy name and age here. Now, in this array, in this memory space, do we have for Alice the faculty and do we have the company for Bob here? No. Why? Because upcasting at objects level, you lose the specific part. So in this array, you have only the person part from all these objects, and you can't recover it. You can't go back from a red box to a red box and a green box because you don't know what was here. So working with static arrays of persons is not okay, because when you do upcasting, you lose everything. So it doesn't matter if we overread and print info in student or software engineer, because print info here will always be executed for a person, because here you have only the person part. Okay, so here you don't have faculty, here you don't have company, because you have only the person part, which means name and age. Okay, now the idea, it's great, right? So we need to follow it. So it looks like that arrays of objects, arrays of objects, static arrays of objects, they don't work. So let's try with the dynamic one. So here I will say person, everyone, and here I will say everyone equals new person of 3, and then I will do this. Okay, now let's see if this solves the issue. So build, rebuild, debug start without debugging. Let's give it another try. Debug start without debugging. And now we have this again, the output from the person. So let's think for a moment. Let's see, even if we are disappointed, let's understand why this is still not working. So what's the difference between this and this? If I will draw the memory again for all this stuff, when we have defined a static array, that static array was where? On the main stack, right? We discussed this many times. So this was version 1 with the static array. Now, when you have a pointer, then we have a pointer on the main stack, but the array new person of 3 now is where? in heap. So instead of having the array here on the main stack, now we have the array in heap. But let's check the array. Is any difference between this one? So this is main stack. This is heap. Is any difference between, and here between these two, you have a pointer. It's anything different. So here you have a sequence of red boxes, and now we have a sequence of red boxes in heap. So the only difference is that this array now is in heap and this array was on main stack, but they look the same. So the explanation from before, the reason for initial reasons based on which we have seen why this doesn't work, that you copy only the red box into the person part here, you copy only the person part, is the same reason for why this solution doesn't work. So defining a static array of persons or defining a dynamic array of persons, from this perspective, looks the same. Now, let's try to change the perspective. Let's try to introduce to play only with pointers, only pointers. What do I mean? Let's define array of pointers to person. Now, it doesn't matter if you do this array dynamic or static. So let's simplify a little, at least from this perspective, the story. So here, let's define, so this is an array of pointers to persons. Okay. So what's the difference between this one and this one? Here you have an array of 3 objects. Here we have an array of 3 pointers. Okay. Now, this is a static array, okay? But the content are pointers. So let's initialize them. So I want to initialize the first pointer with the address of John. So we know how to get the address of John. It's like this, John. Okay. Now let's initialize the address of a second pointer. What's the issue here? Sorry, I have this redefined. Yeah. 1 second to comment these lines because I have the same array. So everyone index 1 equals address of Alice. Everyone index 2 equals the address of Bob. Engineer Bob, sorry. Engineer Bob. So now, because these are pointers, I can't use dot anymore, but I can use arrow. Okay, so some of you will say, okay, so you just complicated 1,000 times the solution. What's the idea? So instead of having a static array of objects, now we have a static array of pointers to objects. So what's the difference? Are we closer to the solution or not? So let's draw again the memory.
Teacher?
Yeah.
Now I'm getting an error on line 144. Array of pointers to persons, array of 3 pointers, static array, but content are pointers.
So you have the arrow here?
On the everyone word.
So you have a pointer here. Yeah.
Yeah.
This is commented, right?
Yes.
Okay. And now you have here, you get the address of John, Alice, and Engineer Bob. Okay. Yes. And here you have everyone arrow print info, right? Okay. So if we run this, let's see what will happen. Start without debugging. At least it didn't crash, but we have the same output. Again, we are disappointed. So let's see why it's not working now. So if I draw the memory, we have in memory John, right? So they are somewhere on the main stack. It doesn't matter, or in heap. So this is again John. After that, we have Alice somewhere in memory. And here we have Engineer Bob. And obviously they have extra boxes. This is Alice with the green box. And this is Engineer Bob with its blue box, where you have the company. So this is John. This is Alice, and this is Engineer Bob. Okay, now, how this array looks like now? So if I will draw this array, you have what? You have an array of pointers to persons. So they are pointers, which means they have 4 bytes because we are on x86 architecture. So let's draw this array. So you have a small box, 4 bytes. You have another small box, 4 bytes. This is a pointer, and this is another pointer. And this is everyone right now. And we know when we execute this line that the first box here will take the address of John, right? So you have the address from here. The next instruction will say, take the address of Alice. And now the third one says, take the address of engineer Bob. So what do we have here? We have an array of pointers, which is this one, orange boxes, because they are pointers. And we see that upcasting works also at pointer level. If you ask everyone at 0, what's your type? It will say, hey, I'm a pointer to a person. But because upcasting works at object level, it works also at pointer level. So if you have a pointer of your parent type, you can handle the address of a subclass type, like student, software engineer in our case. So upcasting works also for pointers. So right now, we have here in this array of pointers, the address of John, the address of Alice, which is a person plus a student. And here you have Bob, which is a software engineer. And now we go through the pointers and we call print info. And I think some of you see now that we are kind of close to what we wanted to achieve. Why? Because if you ask this pointer, what are you? So you go to this pointer and say, hey, what are you? This pointer will say, hey, I'm a pointer to a person. And now the compiler will say, so if you are a pointer to a person, let's call print info from person, right? It makes sense. But if we see this image, it's kind of painful because when you reach I equals 1 and you are actually calling print info for this pointer here, this is like asking Alice. So you have the address here, and at this address, you have the entire Alice object, the person and the student. And this is like asking Alice, hey, what are you? And Alice is saying, hey, I'm a person which is enrolled. And now the compiler say, I'm not interested. So it's just interrupting Alice. But Alice was trying to say, I'm a person which is a student at XIE. So you have all the data here in memory at this address, and you have the address here. It's kind of a pity because here the compiler is not seeing that at this address is in fact there is a student. So you see, if we make the compiler to see that at this address you have a student and at this address you have a software engineer, Evrika, we solve this because it should call print info for a student here. It should call print info for a software engineer here because this is a software engineer and this is a student. So how can we make the compiler see what's there in memory, not just because now the compiler is very trivial. It's just checking the pointer type. Okay, so it's asking what's this pointer type? It's a person. So I will call print info from person. Easy decision. There are 0 risks to do any mistake. So how do we convince the compiler to see what's here? And the magic word for this is virtual. So you see, I'm not changing anything here. So let's run this again. Let's clear the drawings. So I will run this again. I will show you again the screen. So you see, we see only print info from the person part. And now I will go here in the person class here, and I will write one keyword here before print info. And I will just write virtual. You see, it's a blue, it has a blue color because it's a C++ keyword. So I did only this change. And now I will rerun the solution. So debug, start without debugging. And let me show you the output. You see it? John, 21 years old, Alice, 20 years old, enrolled at CA. John Doe, 18 years old, company Apple. So right now, we have it. We have a solution by which we can define a single container, a single box, into which we can place students, software engineer, and persons, because they are all related. And if you have methods, virtual methods, which are overridden, here is ears, okay? If you have methods, virtual methods, which are overridden in these classes, you see it's overridden here in student, it's overridden here in software engineer. When you run this program and you call print info, by magic, it's like the compiler now knows that the first pointer is pointing to a person, so it will call print info from a person. The second pointer is pointing to a student, so it will call print info from student, and the same for software engineer. So right now we can write the solution like this. You don't need 3 arrays. You need only 1 array, but what's the catch? The array should be of pointers to objects. So this will never work with this stuff, never. Virtual will never work with this because you have only red boxes. So this works only with pointers to your parent type. And after that, you place everything here by their address. And if you process them by using the overridden methods, things will happen dynamically. Okay, now there is no magic here. The explanation is based on the fact that objects now, they have their function addresses. They have a table of pointers to virtual functions. So actually each object has a hidden attribute. Fortunately, we don't need to manage it. It has a hidden attribute, which is used by the compiler to say, hey, the print info for student is at that address, and so on. So there is nothing magic here. This mechanism is transparent to us as developers. We should know only this, that this is the way we should code from now, okay? To have all this stuff linked together by pointers to this parent type, to have methods to override them, and so on. Now, because this is the way to code, in Java, when they designed the language, they made this decision for us. So in Java, all objects are managed by references. So in Java, when you will write in 1 month from now, student Alice, this is a pointer by default. So it's not an object like we know it in C. It's a pointer, it's a reference. And in Java, all methods are virtual. Actually, in Java, there is no virtual keyword because all the methods by default are virtual. So Java, you see, they took the idea of object-oriented from C++, and they simplified the syntax, and they choose for us the only way which will work, which has the most benefits. Everything, it's a pointer, and all the methods are virtual. And this is Java. And if you don't know C++, you can say, hey, it's easy because it has a simpler syntax. Everything, it's a pointer, but you don't realize that they are pointers. It's like a naive word until you really understand the language. But for you, this is a different story because now you will really understand and you will actually feel and see why Java is simpler, because now you went through this course where you have this duality, either pointers to objects or just objects. And it's the same way C# has done it. But in C#, Microsoft said, hey, maybe there are sometimes cases where you don't want to have your function virtual. Maybe you want that. So in C#, you can choose if the function is virtual or not. But in Java, they already made that decision. So you don't have virtual in Java because they are all virtual. And this is the virtual concept of methods. Now, what is this? I will just give you for 1 or 2 minutes a short definition, and I will continue next week. So I will finish explaining you. So a virtual, let's say a virtual pure method is something like this. And I will explain you next week what's the use of that. So it's easy. but I need 10 extra minutes, and I said we will finish with the quiz. So a virtual pure method is a method which is declared virtual, okay, but has no body. And the idea is that when you inherit this class, you are kind of forced to override it, because by overriding it, you provide a body. So this is a virtual pure method or an abstract method, aka abstract. Now, when you have a class which has one method like this, you see it has no body. And in order to say to the compiler, hey, it doesn't have a body because I wanted, that's why they use this equals to 0, which looks strange, but this is the way they solve it. So when you have this equals 0 means the function has no body on purpose. So in that way, the compiler will not say anything. So this class at this point is useless because you can't use it, because it has a function without a body. So no one will allow you to create an object. So if you try to create an abstract person object, let's say AP, you get a compiler error saying objects of abstract class is not allowed, and it's giving you the reason. You have a virtual pure function. So what's the idea of this? And generally, these abstract classes will be used to force the programmers to code in a very particular way, in a specific way. And I will show you this next week.